A very good morning to one and all. I welcome you all for this session. Number 26. In this session, we will learn about generalized velocity and generalized force. Let's recollect what we have studied in previous class. We studied about generalized coordinates. We have seen for a simple pendulum motion, we need theta, which is equal to q1 as a generalized coordinate. Likewise, a particle moving on a surface of a inverted cone, here we need r and phi as q1 and q2 as generalized coordinates. So the set of independent coordinates which are sufficient in number to describe completely the state of configuration of a dynamical system represented by q1, q2, q3, so on up to qn is known as generalized coordinates. The learning objective of this session is to understand the generalized velocity and generalized force. By the end of this session, you will come to know what is generalized velocity and generalized force. So let's start. We know that the position vector in terms of generalized coordinate is given by Ri is equal to Ri as a function of q1, q2, q3, so on up to q3n. Differentiating this expression partially, we arrive at dou Ri by dou q1 into delta q1 plus dou Ri by dou q2 into delta q2, so on. So it can be represented in summation form as delta Ri to be equal to summation of I is equal to 1 to n dou Ri by dou qj into delta qj. This represents a generalized displacement. So if you want generalized velocity, all we need to do is differentiate generalized displacement with respect to time. So generalized velocity is the time derivative of a generalized displacement. So differentiate the above expression with respect to t, we arrive at summation I is equal to 1 to n dou Ri by dou qj into delta qi dot by delta theta, which is qi dot plus dou Ri by dou t. So this is an expression for generalized velocity. To know about generalized force, we know that the work done is equal to force into virtual displacement. So delta W is equal to summation Fi dot delta Ri. Now substituting displacement delta Ri, which is given by summation j is equal to 1 to n dou Ri by dou qj into delta qj, and rearranging, taking this term as qj, so q then delta w becomes summation of j is equal to 1 to n qj delta qj, where capital Qj is equal to summation of j is equal to 1 to n Fi dou Ri by dou Qj. And this expression is known as generalized force. So in this session, we learned what do you mean by generalized displacement, generalized velocity, as well as generalized force and their expressions. Now let's have a small MCQ session. Question number 1. Generalized velocity is a time derivative of, you know that it is the time derivative of displacement. So option A. Question number 2. If the generalized coordinate is time independent, then the condition is, if position coordinate is independent of time, then dou ri by dou t is equal to 0. If the generalized coordinate is independent, is time independent, then the generalized velocity expression is, generalized velocity expression is ri dot is equal to summation I is equal to 1 to n dou ri by dou qj into qj dot. So option is A. Delta ri is used to represent, you are seeing, it is used to represent generalized displacement, but we don't have any option, so the answer is none of the above. Option is D. Dou ri by dou t is equal to, which is a rate of change of position vector, which is a displacement. So I have option A r dot as well as C V, they both are same, so the option will be D. Answer is both A and C. Question number 6. Work done is defined as the product of, you know that it is defined as force into displacement. So the option is C. Question number 7. Delta W is equal to, you know that it is a summation of I is equal to 1 to n qi delta qj. So the answer is question number 8. Qj is known as, you know, we have seen it is a generalized force. Question number 9. Qj, which is equal to summation fi dou ri by dou kj, is an expression for, you know that it is a generalized force. Generalized force is obtained, we have seen, we have obtained by using work is equal to force into displacement formula. So the answer will be option C. Small correction, it is option C. Hope you have enjoyed this session. Thank you all.